Preparing for a AI ML engineering at Goldman Sachs interview. You've reached Candy Mentor, and this video is for you. We'll walk through 15 key questions you're likely to face. For each question, you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you explain and diagnose the bias-variance trade-off in a machine learning model used on financial data? Bias-variance trade-off explains whether a model is wrong because it is too simple or too sensitive to training data. In practice, I diagnose it with train versus validation performance. High train and high validation error suggests bias. Low train error and high validation error suggests variance. For financial models, I avoid overfitting to historical regimes by using regularization, simpler features, walk-forward validation, and stress testing across market conditions. While answering, focus on diagnosing underfitting versus overfitting, train validation gaps, regularization, cross-validation, and why noisy financial datasets require careful validation across different market regimes before deployment. Question 2. For a trading or risk model, why is a random train test split often wrong? And what validation strategy would you use instead? Random splits are dangerous for market or transaction data because they let the future influence the past. I use chronological splits, then walk-forward or rolling window validation to simulate deployment. Features must be computed using only information available at prediction time, including lagged prices, volumes, and macro data release timestamps. I also keep a final untouched holdout period, preferably covering stress events, because average performance can hide instability across regimes. Make sure to cover time-aware splits, walk-forward validation, avoiding future information, point-in-time features, release timestamps, and why random train test splits can overstate performance in market data. Question 3. What is data leakage, and how would you detect it in a model built for financial transactions or client behavior? Data leakage happens when training uses information that would not exist at inference time. In finance, leakage can be subtle, using revised fundamentals, post-trade labels, same-day aggregates, or customer outcomes created after the decision. I prevent it by defining a prediction timestamp, building point-in-time features, separating entity groups, and reviewing feature lineage. If validation looks unrealistically high, leakage is one of the first things I investigate. In your answer, talk about prediction timestamps, feature lineage, revised data, label timing, entity overlap, suspiciously high validation scores, and practical checks used before model approval. Question 4. How would you evaluate a fraud detection or AML alert model when the dataset is highly imbalanced? For fraud or AML alerts, accuracy is almost useless because negatives dominate. I focus on precision, recall, F1, PRAUC, and cost-weighted business metrics. I usually tune the decision threshold based on investigator capacity and false negative risk. Techniques include class weights, focal loss, stratified sampling, anomaly detection, and better behavioral features. The final model should improve alert quality in production, not just maximize an offline score. Be sure to mention class imbalance, why accuracy fails, precision recall trade-offs, threshold tuning, business costs, investigator capacity, and techniques such as class weighting or anomaly detection. Question 5. Why is model explainability important in banking? And how would you explain an individual model prediction? Explainability is part of making a model usable in regulated environments. For linear or tree models, I start with global feature importance and partial dependence, then use local methods like SHAP to explain individual decisions. I check whether explanations are stable, intuitive, and free from proxy discrimination. At Goldman-style scale, explainability also supports model validation, trader trust, audit trails, and faster debugging when predictions shift. While answering, focus on regulated AI expectations, global and local explanations, SHAP, feature importance, proxy variables, auditability, stakeholder trust, and limits of black box models in banking. Question 6. Design an end-to-end ML pipeline for a financial risk model at Goldman Sachs. What components would you include? I would design the pipeline around reproducibility and controls. Raw market, client, and reference data lands in a governed data lake. Then point-in-time feature jobs create versioned training sets. Training runs are tracked with code version, parameters, metrics, and approvals. Models deploy through CI/CD to batch or real-time serving, with monitoring for latency, drift, and business KPIs. In finance, auditability is as important as model accuracy. Make sure to cover data ingestion, point-in-time feature generation, experiment tracking, model registry, CI/CD, approvals, monitoring, batch versus real-time serving, and reproducibility for audits in financial institutions. Question 7. When would you choose batch scoring versus real-time inference for an AI/ML system in financial services? Batch scoring fits use cases where decisions tolerate delay, like daily risk reports or portfolio analytics. Real-time serving fits fraud checks, pricing assistance, or client personalization, where milliseconds matter. I choose based on latency, freshness, cost, and operational risk. Real-time systems need caching, feature consistency, fallbacks, and strict SLAs. Batch is simpler and often more reliable, so I avoid real-time unless the business value justifies it. In your answer, compare latency requirements, data freshness, feature consistency, operational complexity, fallbacks, SLAs, cost, and examples like fraud scoring versus daily risk reporting at banks. Question 8. What is the difference between AUC and calibration, and why does calibration matter for risk models? AUC measures ranking quality, not whether predicted probabilities are correct. A model can separate risky from safe accounts well, but still say 0.8 when the true event rate is 0.3. In risk, pricing, and capital allocation, calibration matters because probabilities drive money decisions. I check reliability curves, Brier score, and calibration by segment. If needed, I apply Platt scaling, isotonic regression, or recalibrate after drift. Be sure to explain that AUC measures ranking, calibration measures probability correctness, and connect this to risk, pricing, capital allocation, Brier score, and reliability curves. Question 9. How do L1 and L2 regularization work, and when would you use them in a financial ML model? Regularization constrains a model so it generalizes better instead of memorizing noise. L1 can drive coefficients to 0, which helps feature selection. L2 shrinks weights smoothly and is useful when features are correlated. For neural networks, I also use dropout, weight decay, early stopping, and data augmentation. In financial data, regularization is critical because signal-to-noise is low, and patterns can vanish quickly across market regimes. While answering, cover L1, L2, dropout, early stopping, feature selection, correlated features, overfitting, and why low signal-to-noise financial data benefits from regularization during model development and deployment. Question 10. How would you build a retrieval-augmented generation system for internal financial research documents? For internal research documents, I would prefer RAG over fine-tuning as a first step. Documents are chunked, embedded, stored in a vector database, and retrieved at query time with permission filters. The LLM answers using retrieved context and cites sources. I would evaluate retrieval quality, hallucination rate, latency, and data leakage. Fine-tuning is useful later for style or domain tasks, but RAG keeps knowledge fresher and more controllable. Make sure to cover embeddings, chunking, vector search, permission filtering, citations, hallucination control, evaluation metrics, and why RAG may be safer than fine-tuning for internal knowledge. Question 11. Once an ML model is deployed, how would you monitor it for drift and production degradation? I monitor 3 layers: data, model behavior, and business outcomes. Data checks include missing values, schema changes, feature distributions, and population stability index. Prediction checks track score distributions, confidence, latency, and error rates when labels arrive. Business checks track alert conversion, P&L impact, or risk metrics. When drift appears, I investigate upstream data changes first, then retrain, recalibrate, or roll back if the model is unsafe. In your answer, discuss data drift, concept drift, schema checks, prediction distribution monitoring, delayed labels, PSI, business KPIs, alerting, retraining, recalibration, and rollback decisions for production models. Question 12. How do you handle missing values and outliers in financial datasets? Missing values are not just a nuisance. They often carry signal. I first understand why data is missing: system failure, delayed reporting, or customer behavior. For numeric features, I may impute with median, model-based values, or explicit missing indicators. For outliers, I verify whether they are errors or valid tail events. In finance, I avoid blindly clipping because extreme values can represent the exact risk the model must learn. Be sure to mention missing miss mechanisms, imputation strategies, missing indicators, outlier validation, robust statistics, tail events, data quality investigations, and why blind clipping can be dangerous. Question 13. A feature engineering job in Python is too slow for large financial datasets. How would you optimize it? If I see a slow training job, I profile before optimizing. I check data loading, joins, serialization, feature computation, and model training separately. Common fixes are vectorized pandas or polars operations, pushing aggregations to SQL or Spark, caching intermediate features, and using efficient file formats like Parquet. I also reduce feature cardinality and sample intelligently for experiments. The goal is faster iteration without changing the statistical meaning of features. While answering, focus on profiling first: vectorization, efficient joins, SQL or Spark pushdown, caching, Parquet, cardinality reduction, and preserving feature semantics while improving speed for experiments. Question 14. What does model risk management mean, and what documentation would you prepare before production deployment? Model risk management means proving the model is appropriate, controlled, and understood. I document the objective, data sources, assumptions, limitations, validation results, and monitoring plan. Independent reviewers should be able to reproduce training and challenge the methodology. For a bank, I would include stress testing, explainability, approval workflow, and rollback procedures. A high-performing model that cannot be governed is not production-ready, regardless of leaderboard metrics. Make sure to cover documentation, assumptions, independent validation, reproducibility, stress testing, explainability, approvals, monitoring, rollback plans, and why governance matters in a bank before production deployment. Question 15. For tabular financial data, how would you choose between logistic regression, gradient-boosted trees, and deep learning? For tabular financial data, I rarely jump straight to deep learning. I start with a logistic regression or regularized linear model as a baseline, then try gradient-boosted trees like XGBoost or LightGBM because they handle nonlinearities and mixed features well. I compare accuracy, calibration, latency, explainability, and stability over time. Deep models can help with text, sequences, or huge data, but simpler models often win in governance-heavy environments. In your answer, compare linear baselines, gradient-boosted trees, deep learning, tabular data, calibration, explainability, latency, stability, and governance constraints, common in financial institutions like Goldman Sachs. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.